Okay, here we go. First class day of 2020. Woo! All right, don't be that excited, everybody. Okay, so we just went over our little activity with graphing sine and cosine on your own. It looked phenomenal. Great job, everybody. I'm going to start going over how to graph these when we start changing those parent functions. Okay? So first off, every graph we do is going to be in radian mode unless you either see a degree sign or it says do it in degrees. Okay? We just do everything in radian mode. Just easier that way if we do that same thing. So the values for the domain and range, we just did the domain and range for both of these. What are they? Negative infinity to infinity, you all said. That's great. Range is -1 to 1. That's great. You're all phenomenal here. Go 2020. Cosine has the exact same domain and range. Who put 2019? Who writes the date anymore? This is not an actual paper? This is imaginary. Okay, so here, functions. I got a hole punch. That's supposed to be an F. So functions are repetitive. Functions that are repetitive or cyclical, like sine and cosine, are called periodic. So because they're periodic, they are going to have an actual period. So I kind of talked about that a little bit here. I'm kind of just moving right down to the period is how long it takes on the x-axis for the cycle for the function to go through one cycle. So a period is how long it takes to go through one cycle. Parent function for sine, it's going to be 2 pi. All right. So the period of sine and cosine is 2 pi. Why is that true? Because one cycle. I can't spell cycle. One cycle lasts 2 pi. And then starts over. Okay? Not today. Or maybe today. I lied to you. Oh yeah, I completely lied to you. I thought this packet had more trig functions. We're just doing all sine and cosine. I'm going to kind of skip through some of it. Gets a little repetitive. Like for this, do I really need to do this again? Did we just do this activity? We just did this? Let's move on.
Okay, but wait, what about what does this mean, equation?
Oh. Here's the following statement, sine and cosine, and then let's talk about it. Well, that's just, is that really not important right now? It will be important, like in a sec, like tomorrow. No, it gets important right here. Like this is when I really start to care about it.
Oh, okay.
All right, so right now I don't really care about it. Let's just go right here to talk about stretching it with amplitude. So the number in front is going to affect the amplitude of it, just like any other function. Like if we just have like a parabola, right, of just x squared. What happens when you put a 3 in front of it? It gets bigger. We stretch it, right? It gets bigger faster. What do you think is going to happen to a sine and cosine if I do that? Just going to stretch it. Okay, so that's amplitude. Amplitude is how much are we stretching this thing by. All right, so typically the range is from -1 to 1. If I start to multiply this by 3, guess what happens to the range? Multiplies by 3, so go from -3 to 3. Again, this is on the parent function. When I start moving up and down, yeah, it's going to change a little bit. So if I just want to graph the following right here, and if you notice, I'm going to be giving you mostly blank graphs. All I care about is that you graph one cycle. If it says you have to graph 2, you have to graph 2. But if it doesn't say anything, just graph one cycle. I am lazy. One cycle. I don't do 2. That's too much for me. One cycle. Graph one cycle. Graph one cycle. Okay. Oh, I almost got it. Okay, so when I graph cosine right here, you really need to start to memorize how cosine works. Okay? So, what's the highest point of this cosine? Not, it used to be 1, but in this case it's 1/2 cosine x. It's a half. And what's the lowest point? I always graph 5 points. That's all I graph, 5 points. So obviously this point right here, 2, 3, 4, 5. Okay? I'm graphing one cycle. So if I start at 0, where does it end? If the period is 2 pi, it's going to end at 2 pi. Okay? So those are the endpoints. So this is going to be 0 right here. You don't need to label 0, but I will in case we get lost in the world. This is the very middle point. What's smack dab in between 0 and 2 pi? Pi. What's smack dab in between 0 and pi? What's smack dab between pi and 2 pi? 3 pi over 2. Okay? This is going to just need to start coming from memorization. Okay? So it's I'll do green. So this is my, what do they call it? Transverse axis? Alright. I might call it a sinusoidal axis. This is what I'm used to. Sinusoidal axis. Or transverse axis. Sinusoidal makes it sound like cooler, so I'm all about that. So I just do a little dashed green line. You don't have to do it. I just do it for my teaching purposes. You really can't tell where it is. That's okay because it's at 0. So it's not that big of a deal. Cosine always goes... Oh, I broke that one really quickly. Cosine always goes up, middle, down, middle, up. If you don't believe me, look at the picture you just drew on that other sheet. Starting from 0, for cosine, it goes up, middle, down, middle, up. It's okay. You're allowed to. But you better not at quiz time. Okay? Now, are these straight lines? It's supposed to be a little curvy, so it should look like this. Little curve right there. Little curve right there. Little curve right there. Little curve right there. What's my range? So that's cosine. Positive cosine is up, middle, down, middle, up. If you don't know that, then you can just, hey, what's cosine of 0? It's 1. Oh, so 1 is up. What's cosine of pi over 2? It's 0. Oh, it's middle. What's cosine of pi? It's negative 1. Oh, so that's down. And you can kind of go through. That's just another way to do it. I'm just trying to show you many different ways to know this. If you want someone to go, it's up, middle, down, middle, up. Totally cool. I'm not going to do the second one because it's the exact same thing, except I would really just erase the 1/2 and replace them with a 3. So do we need to do that one again? I didn't think so. But I do want to talk about this one right here, in case we negate it. Okay? So, I wish this was... I'm just trying to think of a better way to do this. Hey, let's go back to that previous one. I'm going to change the previous one. Then I can skip the sine one, because the notes are stupid. Why the heck would you talk about sine? We haven't talked about it yet. Hey, I'm going to change... What's that? I'm going to do with the 3, just make it a negative 3. I'm going to do this one and make it a negative 3. So it's going to change it a little bit. Okay? If it's positive, I said it's up, middle, down, middle, up. If it's negative, it's going to be the opposite. It's going to start it to down. So we're going to do really the same exact idea. So the period's going to go to 2 pi. The middle of that is pi. Then we got pi over 2. Then we got 3 pi over 2. These aren't a big deal yet. They will be a big deal here in just a moment. Top one is, don't say negative 3. The top one is 3. Woo! The bottom one is negative 3. It does not need to be the scale. You just write those numbers, and I'm totally cool with it. And we kind of just said this. It's going to be the opposite. So instead of being up, it's going to be down. Middle still. up, middle, down. No, you're not. I was focusing on my graph. What's the range? Don't say 3 to -3. -3 to 3. Numbers go in a certain order. Okay? So that negative, all it does is just flip the order. Okay? Alright, let's talk about the period now if I change the period. So, what's going to change the period is if I have a number that's inside of the cosine or the sine function. That's going to change the period. Okay? How does it change it? Well, there's this lovely little formula here you kind of really have to memorize. It's 2 pi divided by whatever that number is in front. That's what's going to change my period. Okay? The reason is because it's a horizontal shrink. Okay? Remember, if that number in front is bigger, it horizontally shrinks it. If the number in front is smaller, it horizontally stretches. Just like if I had like a +2 like inside the cosine, would that go left or right? It would go left. Okay? So horizontally, everything's just the opposite of what you would think it is. So in this case, we're dividing by the 2. So this period is equal to what? For this cosine of 2x, what's the period? Just pi. Alright? So now, let's go ahead and graph everything. First off, what's my altitude going to be? What's my highest number, lowest number? 1 and -1. My period, so I'm going to go out to, not 2 pi, but pi. Does not need to be the scale. It goes out to pi. I'm not asking you to graph 2 of these things. I'm asking you just to graph 1, unless it says you have to graph 2. What's between 0 and pi? Pi over 2. What's between 0 and pi over 2? Pi over 4. What's between pi over 2 and pi? You'll get used to it.
I have a question.
Go for it.
So the 2x means you do the opposite. Is that what you said?
Yeah, so instead of multiplying it by 2, we divide by 2. Let's go ahead and graph it. So cosine is what again? If it's positive, cosine is up, middle, down, middle, up. Okay? Alright. So if you're given, I don't know, I'm just trying to see like the practice worksheet you're given here. No, we're good here. No, I think we're good. Yeah, no, we're good. Alright, hey, that's all you need to know. Okay? Yes! I'm so glad we're doing a sine problem now. So let's go ahead and tackle the sine problem, and I'll tell you the pattern. And you can you can even just look at the sheet you just did and figure out the pattern as well. But let's just go through this. So for this one, the period's going to change. What's the period going to be here? How do you know it's 4 pi? Right. So we're dividing by a 1/2, because that's the same thing as sine of 1/2 x. Okay. So it's 4 pi. So we're going to go from 0 to 4 pi. What's in the middle of 4 pi? 2 pi. And you kind of get the idea, right? I'm glad it does. How high do we go? Very good, class. 1 and -1. Confidence you're giving me is awesome. Again, so we didn't talk about sine yet. Middle.
Middle down, middle.
Middle top, middle down, middle.
Yeah. Right?
Yep. So for sine, it's middle top, middle down, middle. Or middle up, middle down, middle, whatever I was saying.
Look. How do you get your graph so pretty? Mine looks like
Years of graphing. Years and years and years and years of graphing.
okay. I'm just don't plan on graphing for years.
That's a shame. Everybody asks me, hey, what am I going to use in real life? I graph these all the time. All right. Okay, so hey, we can do one up here where it does the two things we just did. We changed the amplitude, we changed the period. We don't need to do that though, right? Okay. Let's start talking about the translations of them. So these are all different transformations, by the way. So we did stretching vertically, stretching horizontally. Now we're going to do moving right, left, up, down, whatever. So really, here's like the formula part of it. Okay, so the first number right in front is amplitude. The period is that 2 pi over b. I like how that's taken off right there. I'm going to say that's the letter C. Is the horizontal shift, and then D is the vertical shift. Okay?
Okay, wait, what's the difference between the one on the left and the one on the right? Oh, okay, nothing? They're the same thing?
I feel like this should say cosine right there.
Okay.
That's just,
Who writes these notes?
not me. All I do is make fun of them, so I better not write them.
You're writing them.
We are in...
I love my Uncle Pete, he's so funny. He's from Chicago.
Ugh, Chicago. Okay. Hey, let's get rock and rolling here in 1. So this has got quite a few things going on here. The first thing I'm going to do is I need to know where my transverse axis is or my sinusoidal axis. It's always been at 0, so I've been ignoring it because we had to move it up or down. But in this case, what am I doing to this graph? I'm going down 2. So I'm going to label this as 2. And this is where I'm going to draw my dotted green line. Maybe.
Why? Okay, can we break it apart? Like, why? Yeah. Here's a log number. Can you, like, write down next to each in the equation? Does that make sense? Okay.
Did I just do it what you just asked?
Yeah. Because I need to take it piece by piece.
Fine. What's the 2 represent? The vertical stretch, or the amplitude in our case. So the amplitude always starts from the transverse axis. So I'm going up 2 and down 2. So starting from -2 and I go up 2, what number do I reach? Oh, so I get to 0, and if I go down 2, I get -4. So now my entire graph I'm graphing is going to be in between these 2 lines right here. Okay? All I did was just take the graphs that I just had, I just moved them down 2. Okay? And what does this 1/2 represent? It's going to represent the period. So what is the period in this one? Because it's 2 pi divided by 1/2, which is going to give me 4 pi. Okay? So, I'm just going to graph them right on the sinusoidal axis for you. Is that cool if I can just, I'll leave them right here? So, that's 4 pi. That's going to be 2 pi. That's pi. That's 3 pi. I understand that labeling on the axis. You can if you want. I just want to be consistent here. Cool with that?
Wait, what did you just say?
I just labeled everything on the sinusoidal axis, or the transverse axis.
Oh, okay.
Instead of labeling it on the x-axis, just to kind of help you out a little bit visually. Okay? So this is cosine. So what's the order going to be?
Top, middle, down.
And what's this range?
Um,
What's the lowest point? -4 until?
they're getting better. They're getting more cursive. Oh, Avery, no ask for your. Okay, this is just so overwhelming.
Good.
I just don't know where to start.
I'm telling you where to start. I'm telling you. So the first thing we do is what?
Look at the down in the left.
Yes, the down or the up or the whatever. So we're going to do that first. Okay? So that's the vertical. Let's focus on the vertical. So what's my vertical? What's going on to it? So we're going down 3. Okay? Let's talk about my amplitude now. So if I go above -3, what's the highest number I reach? 3. If I go below -3, what's my highest number going to reach? -9, which is like all the way down here. So I'm just kind of extend this line. I think that's the scale. Close enough, at least for what I'm doing. Okay? Let's go ahead and do where I'm starting this from. I usually start at 0, but what's happening right now? It's going left too. So instead of starting at 0, I have to start at -2. What's my period? Well, we're going to do 2 pi divided by this pi over 4. This one's a little bit trickier, but what's nice is the pi's are going to cancel out. So what's my period going to be? 8.
Okay, hold on. How do you do? Wait. Where did you get 2 pi divided by pi?
So it came from here. Period is always 2 pi divided by b. Okay? And this right here is my b value. Okay? So it's 8. Think about this. Am I starting from 0 to count over 8? No, I'm starting from -2. So I count from -2 and I go over 8. What's my magic number? 6. I understand this is where it starts to get a little difficult when I start moving it left and right. Up and down I think is not too bad. Left and right is a little bit difficult. So I'm starting at -2. Because of my period, I'm going to go over 8 and I get to 6. What number is smack dab in between -2 and 6? If you don't know, add them together, divide by 2. They're called being averages. What's smack dab between -2 and 6? It's 2. What's smack dab between 2 and 6? Don't know, find the average. Add, divide by 2. You're going to get 4. What's smack dab in the middle of -2 and 2? 0. Well, that's kind of nice. And this is a sine, so I'm going to start 0, up to whatever the highest point is that I already mentioned. Middle, down, middle.
That is an intense graph.
This is intense. It just has a lot going on it. It's so at this point we should be totally fine. You should be able to graph this at this point. The only thing that you can mess up here are these numbers. The shape should always look the same. It's the numbers that might look a little weird. I've done better, but whatever. And what's the range of this one now? Look at the graph. Negative 9 to 3. Questions, comments, concerns? We're done. I know, it's so sad. The first lesson is over in 2020.